Okay, ladies and gentlemen, let's go ahead and let's take a look at doing the various areas of a triangle. So we have area of triangle. Now, for the area of a triangle, it's very simple. Normally, area equals length times width or base times height. But because we don't have a full-on rectangle, with a right angle down here where I have H and I have L, or I have W and I have B, take your pick. In this case, whatever this is and this is, that would be a rectangle. For a triangle, I need to make it 1/2 of that, because if I put a diagonal in, now the triangle is going to be exactly half of whatever the base times the height, length times width is. So over here, same thing happens. Even if I have a triangle here that doesn't have a right angle in it, if I had a full-on rectangle that big, I can drop an altitude right here, so that becomes my height. This becomes my base, and it's still going to be exactly 1/2 base times height, because this part here is equal to this part here. This part here is equal to this part here. Now, the ones that get somewhat confusing are a triangle that looks like this. A triangle that looks like this. In this case, it's still 1/2 BH, and the base is still right down here, but the height, when I drop it, it drops to an imaginary line that goes out through here, so this is the height. So base, height, 1/2. Now you say, well, I don't know that I buy that. Well, let's take this, let's spin it around. And so I got this really long side, I got this kind of short side here, and I got this side here. So if I take this and I literally turn it around, not quite 180 degrees, instead of dropping the height out here and doing it that way, with this as a base and this as a height, let's just make this the base, but the height is now in the middle. Okay, so whether I have the height on the outside or the height in the middle, it can sometimes be a bit of a challenge. Now, it's no big deal if I have a right triangle. So I have this, 6, 10, area equals 1/2 of 6 times 10. Cool, that's great. In this case, if I'm giving you a height and I say, oh, that's 3, this is 7, you say, oh, 1/2 of 3 times 7. Not that big a deal, that's going to equal the area. However, if I have something like this, where I have a height that I do not know, and I have maybe a base, which is 10, in this case, I'm going to need way more information than this to find the actual area of that triangle. And so to find the area of this particular triangle, maybe I'm given that this side over here is 7. Well, that's not a height. But if I know that that is 7, and maybe I know that this is 20 degrees, could I say opposite hypotenuse and say sine of 20 degrees equals opposite over 7, and do a little multiplication and come up with whatever the height is and plug that in? Yes, I can. So why did we wait to do some of the areas of triangles until after we had done sine, cosine, tangent? Because in most triangles, they're not actually right triangles, and we're not actually given a height. We're going to have to find it using trig functions. This also applies when I'm looking at something like a regular hexagon. In a regular hexagon, I can break this up into triangles. Now, each of these triangles would be 60, 60, 60, 60, 60, 60. Great. And if I want to drop an altitude right down here, that breaks the 60 up into two 30s. Well, if I got a 30 and a 90, this over here is a 60. And so now I can use 30, 60, 90 triangles to actually find the area of each triangle, then multiply by however many I need. So before long, the area of a triangle is going to become the basis of all the different areas that we need. All right, so that's areas of a triangle.